Number 37. Assume the number of hours of daylight varies sinusoidally at the Clydehurst Christian Range in Montana. The longest day of the year has 15 hours and 30 minutes of daylight, and the shortest day has 8 hours 30 minutes of daylight. How many days during the year have at least 13 hours of daylight? So if this varies sinusoidally, then we know we're going to have to find the equation of a sinusoid. So for simplicity's sake, I'm going to use a cosine graph because a cosine graph we know starts when time equals 0, we have a maximum. So when time equals 0, we have a maximum. Assuming there's no phase shift, of course. So it's going to look something like this. And this will be like the period of 1 year. So if this is time equals 0, then this would be time equals 365. So we have to find the different parts of a sinusoidal equation. First we have to find the amplitude. So to find the amplitude, we just have to find how far it is between the shortest day and the longest day, and then divide by 2. So the low point, I shouldn't have drawn this because that's kind of misleading. The low point is 8.5 hours, and the high point is 15.5 hours. And so the amplitude, this is the midline, not the x-axis, by the way. So the amplitude will be the distance from here to the midline, and also the distance from the maximum to the midline. So to find that, the midline will be halfway in between. So between 8.5 and 15.5, that's just 12 hours. And so the distance from 15.5 to 12, that's 3.5. So we already have two pieces of information. The amplitude is 3.5. The midline is at 12. And then we have to find the period. Well, if it varies sinusoidally and it's over the course of a whole year, then it's pretty safe to assume that this is going to vary over the course of a year. So we can say that the period is 365. So with this information, what we can do is make the equation of our curve. So if we use a cosine graph, then that keeps us from having to use any phase shift. So we're going to have 3.5 times the cosine of, and then this is just the equation you use, 2 pi over 365 times the time, and then you add the midline. So now that we have this, we have to find how many days during the year have at least 13 hours of daylight. So the way we can do that is set this equation equal to 13 and see which days of the year have 13 hours of daylight. So I don't really want to solve that by hand. So what I'm going to do is I'm going to go in here and say 3.5 cosine of 2 pi over 365 plus, I think it was 12, equals 13 hours. And then the way we can restrict this is by setting this on a restriction from 0 to 365. Because as you know, the trig function will continue to oscillate, and we'll have a bunch of days with 13 hours, but we only need the 2 days during the whole year where it's exactly 13 hours. So I'm going to make that stipulation. So 0 is less than x is less than 365. Well, that's awkward. Oh, it's because I didn't multiply by our variable inside here. Here we go. This should give us something. Yes. Okay, so on the 74th day and on the 290th day, we have exactly 13 hours. So we go here, 290.582 minus 74.4179. That means there's 216 days between these two 13-hour days. So let's think about this real quick. So one of them is at 74, one of them is at like 290. So let's see what that looks like on our graph. So we have like 74 and 290. So 74 Okay, if this is 12, then 13 should be something like this. So this right here will be around 74, and this right here will be around 290. And so actually, the difference that we found of 216 will actually be the part that's under 13. And so to find the part that's over 13, we just do 365 minus that. So 365 minus 216.164, and we get 148 days, 149 days, and that's answer choice E. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.